Hey everyone, welcome to your second AP Calculus AB video. This is the second video then for your summer packet, and this is the introduction to graphical limits. So in the first video, we reviewed piecewise functions and we talked about why it was important to look at this first topic, which is limits. So just as a quick review, here's three of the graphs from the last video. And if we look at these three graphs, and we're looking particularly at f of 2, we can see that f of 2 in this first graph is 4, f of 2 in the second graph is 4, and f of 2 in the third graph is 4. So in each case, f of 2 equals 4. Although that's useful information, the function value does not tell us anything about the behavior of the function close to a particular x value. So in other words, we don't know, is it connected and just with different slopes? Is it not connected but the function value is attached to one of them? Or is the function value completely on its own and everything else is all connected? So that's why this first topic of limits is so important. So that's just a quick review from the first video. And let's actually dive into some calculus for you. So the first thing that we're going to talk about then here is a limit. A limit of a function f of x describes the behavior of a function close to a particular value of x. It does not, I'm going to underline that because it does not necessarily give the value of f of x. So in other words, it does not necessarily give us the y value or the function value. All right, so what we do when we've got limits is we write this. All right, I know that's a little weird, it's a little strange. Some of you may have seen it before, but most likely not. But when we write something like this, what we then say is that this is the limit of f of x as x approaches c. All right, and then technically I'm going to make it the limit of f of x as x approaches c is L. We're saying that the actual limit of the function when we get closer to c is L. So this is kind of a lot. It's a little weird. So let's kind of break this down a little bit. Let's first look at this c right here. So we said the limit of f of x as x approaches c. Well, the thing that this c value does is it tells us the x value that we want to approach. Or that we want to get really, really close to. All right, so when we look at this particular graph, here's our c. That's an x value. Could be any number, okay? Then let's also look. F of x we know is a function, so I'm going to just kind of box that off and just write function up here. There always has to be some kind of function in there. A lot of times we write f of x, sometimes we write a particular function. It just kind of depends, but there always has to be something there because it's the limit of this function as x approaches c. Okay, so if we look here on our graph, here's y equals f of x. So that means this line with a hole right here is actually our function f of x. And then the last thing I want to talk about here is this L. All right, that L describes the y value we are approaching. So it doesn't tell us the actual function value, right? That's what we set up here. It doesn't tell us f of c. It tells us the y value that it looks like the function is approaching. So let's go back to our graph right here for a second. We can see here's this x value that we want to approach, and we can see that the graph then is approaching this value L. That's the y value that the function is getting closer and closer to as we get closer and closer to C. So just as a quick note down here, the actual function value at a given x value does not affect the value of the limit. So if we look at this particular graph, if I wanted to find f of c, there is no closed dot here, so f of c is undefined. However, the limit of f of x as x approaches c is L, because the y values look like they would be approaching L. They look like they should be L. It just so happens that at this particular value, it's undefined. All right, I know that's kind of a lot. We're going to look at some examples here and kind of talk through what this really means then. Before we dive into the examples, though, I want to talk about the three different types of limits. This is really not a big deal. We've got right-sided limits, left-sided limits, and two-sided limits, and pretty much it's as simple as it sounds. All right, a right-sided limit looks at the behavior of the function as x approaches the given value from the right side. All right, the way that we write this is we say the limit, and we've got our c of f of x. So this looks exactly the same. The way that we show it's a right-sided limit then is we put a little plus sign after the c. That's the only difference from the limit notation we just wrote on the last page. All right, and then what we say is we say the limit of f of x as x approaches c from the right. And the important part here is that we're approaching the value from the right side, not that we're moving to the right. We're approaching c from the right, okay? Then we've got our left-sided limits. So a left-sided limit looks at the behavior of the function as x approaches a given value from the left side. So we write almost the exact same thing, but instead of a plus sign, we're going to put a minus sign. So instead of, again, the plus, we put a minus, and we say then the limit of f of x as x approaches c from the left. And then we have a two-sided limit. So a two-sided limit looks at the behavior of the function as you move towards the given x value from both sides. A two-sided limit only exists if the limit from the left of f of x is equal to the limit from the right of f of x. In other words, a two-sided limit only exists if both one-sided limits approach the same value. So we're going to talk about what this means, all right? So use the graph below to find the following limits if they exist. If the limit does not exist, write does not exist and explain why. So we're going to talk about how to figure this out and then what that explanation is actually going to look like. So the first thing I'm going to do here is when I look at this first graph, I can see that all of my limits are approaching 2. This one's from the left, from the right, and then overall. So what I'm going to do to focus my attention is I'm just going to draw this vertical line here at x equals 2. All right, and then we know that with a graph and with a particular function, we have a right side So this is the right side of x equals 2, and we have a left side. This is the left side of x equals 2. All right, so what we want to do is if I want to approach 2 from the left side, then that means I'm coming from here and I'm getting closer and closer to the value x equals 2. So when I look at that function value, that happens to be 4. Now if I want to look at the limit as x approaches 2 from the right, then that means I'm going to start on the right side and I'm going to get closer and closer to the value where x equals 2. So in this case, that also equals 4, which means then that my overall limit equals 4. My left and my right equal each other, which means that my overall limit happens to be the same. It also equals 4. And we can see that from both sides, we're approaching the same value. Okay? Let's look at another one. So again, we've got limits as we approach 2. So I'm going to go ahead and draw this line here to focus my attention. Here's the right side of 2, and here is the left side of 2. So part A here asks for the limit of f of x as x approaches 2 from the left side. So since this is the left side, I need to figure out what y value am I approaching. I'm approaching 4. So the left-sided limit is 4. Now let's look at the right side. The limit of f of x as x approaches 2 from the right. So if I look at the right side, that's this line up here. This seems to be approaching 5. So I want to talk really quickly about the open and closed circles. I know it's a little hard to see on my paper, but hopefully you can see on yours. The closed circle is on the left piece here, and there's an open circle on the right side. But that doesn't matter because I'm not looking at the function value, I'm only looking at the limit. So it doesn't matter that there's an open circle there. It looks like it's going to 5, and so that's what the actual right-sided limit is. All right, so don't get tripped up with open and closed circles there. Now I want to look at the overall limit. Well, we said that the overall limit only exists if the left and the right equal each other. These do not equal each other. So we need to say that the limit does not exist. You can go ahead and use a shorthand here though and just say DNE. But we need an explanation. All right, so this limit does not exist because the limit of f of x as x approaches 2 from the left does not equal the limit of f of x as x approaches 2 from the right. So because my two-sided limits don't equal each other, the overall limit does not exist. All right, hopefully you guys are with me. We're going to do a couple more examples before you guys go off and do some on your own. So let's go ahead and look at the next page. And we're going to look at this because there's a lot going on in this graph. So we looked at 2 examples where it was just we had to focus on one little thing and move on to the next graph. Now we're going to look at what happens when we get a graph like this and we have a bunch of different limits that we need to discuss. So we're going to go ahead and go through this. So for this first one, we want the limit of f of x as x approaches -4 from the left. So here's -4. From the left side, I can see that we're approaching 0. The limit of f of x as x approaches -4 from the right. Here's -4. The right side of -4 is over here. And as I move closer and closer to -4, I'm approaching 0. That means then, if I want to look at the limit as x approaches -4, there's no plus or minus sign here, which means this one is my two-sided limit. In order to look at a two-sided limit, we have to pay attention to the left and the right-sided limits. So if I look at the left and the right, they both equal 0. That means my overall limit is also 0. All right, now we're going to focus on -2 for a second. So the limit of f of x as x approaches -2 from the left. Well, here's x equals -2. So if I'm approaching it from the left side, I'm looking at this particular piece of the graph. So as I get closer and closer to -2, it's approaching 2. The graph is approaching 2. If I look at the limit of f of x as x approaches -2 from the right, here's -2, here's the right side of -2. So as I get closer and closer to -2, I'm approaching 0. And now again, I'm looking at the overall limit as x approaches -2, and that means I need to look at my left and right. They are not equal to each other, which means this overall limit does not exist. Because we need an explanation. So the limit of f of x as x approaches -2 from the left does not equal the limit of f of x as x approaches -2 from the right. So because the left and right limits don't equal each other, the overall limit does not exist. Okay, now we're going to look at as we approach 4 from the left. Well, when we look at the graph here at x equals 4, we can see that this is a vertical asymptote. There's a dotted line here, right? So we're not looking for the function value, we're looking for the limits. So on the left side of this asymptote, it looks like this graph just keeps going down and down and down and down, which means that the limit as x approaches positive 4 from the left is going to be -infinity. If we look at the right side of 4, we can see that it's doing the exact opposite. This part of the graph is heading up, and it's just going to keep going on the other side of this asymptote. It's approaching positive infinity. So if I want to look at my two-sided limit here, I can see one of these is -infinity and one of them is positive infinity. That means then that the limit does not exist. Because the limit of f of x as x approaches 4 from the left does not equal the limit of f of x as x approaches 4 from the right. Okay, couple more examples to look at really fast. The limit as x approaches 1 of f of x. So for this one, you should notice right away there's no plus or minus signs here, which means this is also a two-sided limit. But this time I didn't set you up to look at the left and the right first. You're just going to have to do it. So if I want to approach x equals 1, well, let's look at my graph here. This is 0, that's 2, so that means this must be 1 right here. So if I want to look at the left limit and the right limit as I approach x equals 1, I can see that the left side is going here and the right side is going here. So they both look like they're approaching this value right here, which is 1. So remember, even if I don't ask you for the left and the right, anytime I ask you for a two-sided limit, you have to be thinking about the left and the right sides. All right, the last two are just a little different. So the limit of f of x as x approaches infinity. So in other words, we're looking at what's going on as x continues to get bigger and bigger and bigger. So as we move farther and farther to the right, we're following this piece here. And it looks to me like this is an asymptote. This is a horizontal asymptote at 0, which means we're looking at the end of this graph approaching 0. So again, when x is approaching infinity, we're looking at what's going on at the end of the graph. Or in other words, the end behavior. So as we approach positive infinity, this graph is approaching 0 because there's an asymptote. And the very last one, the limit of f of x as x approaches negative infinity, that means we're going to be looking at the other side, and we're looking at this piece. This is going to keep going for forever, and this looks like it's growing for forever and ever, which means that limit is going to be positive infinity. Okay, I know that was a little long. Sorry about that. You guys are going to do some examples on your own now, but I do want to point out, be careful with your limit notation. First of all, you cannot have just the limit as x approaches something without a function there. So if you're not writing a function in there, that's a problem. All right, please make sure that you're doing that. And make sure that you're writing then the correct functions and the correct function values. So for example, if you look at this next page here, this one has an f of h, this has a capital F of x, the bottom one has a p of s, so please make sure you're paying attention to the different notation here and following along with it, okay? Doesn't always have to be f of x. All right, good luck on your practice, and then you've got one more video that you'll need to watch, okay? Thanks for watching.